Hello and welcome to our Year 9 series on linear relationships. So throughout this topic, we'll be looking at the Cartesian plane and how to sketch different straight lines. In this first video, we'll be looking at how to find the distance and the midpoint specifically, in addition to just looking at what the Cartesian plane is. So let's dive straight into it. So let's talk about the coordinate plane. What is the coordinate plane, you may ask? Well, a coordinate plane is a tool used for graphing points, lines, and other objects. It sort of functions like a map that follows directions from one point to another. Now, as you can see, we have a coordinate plane here. We have an x-axis, which is horizontally placed. So you can see this line here, horizontal x-axis. And we have our y-axis, which is vertically placed. Now, in the middle here, we can see there's an intersection of our x and y axes, and this is the point 0. So it's the point 0 for both our vertical and horizontal axis. And we call this intersection, we call this the origin. So whenever you get a question saying a line passes through the origin, well, you know it passes through the intersection of this point. Specifically, the intersection point between these two lines has the coordinate 0, 0. And we'll talk a bit more about this. But basically, a coordinate is where we are on the map. So the first number tells me where I am along the x-axis. And then the second number tells me where I am along the y-axis. So for example, so let's just go through these questions. Label the axes with coordinates. So you can see right now, they don't have any numbers. So if we were to just make each box equal to one unit, then we can say that let's do the x-axis first. So if this is 0, we always define right as positive and going left as negative. So that means this dotted line would be 1, this would be 2, this would be 3, and this would be 4. And since that's positive, the other way would be -1, -2, -3, and -4. And finally, we also have going up and down. So we have 1, 2, 3, 4 that way, and then -1, -2, -3, and -4. Now, question 2 asks us to plot the point -1, 4. So that's the first coordinate. So remember what I said. The first number, so the first number before the comma, is going to be our x-coordinate. So we have an x-coordinate of -1. So it's lying somewhere along this dotted line, which is the x -1 line, and y-coordinate of 4. So it has to lie somewhere along the y = 4. So you can see that this coordinate right here is the one that satisfies both of it. It has an x-coordinate of -1 and it has a y-coordinate of +4. Similarly, this coordinate here, 2, 3, well, that would be this point over here because it has an x-coordinate of 2 and a y-coordinate of 3. And finally, label the origin. What are its coordinates? Well, we've already done that. The origin is this point here, which is the intersection between the x and the y axis. Remember, intersection just means like the point where they cross over. And the coordinate of that would be 0, 0 because it's both 0 in the x and y coordinate. So let's do a little exercise now. So we're considering the points 2, 5 and -1, 1. Plot the points on the graph. That's the first thing. So just to make this graph look nice, I'm going to first write down all my coordinates. So 0, 1, 2, 3, 4, -1, -2, -3, -4, then -1, -2, -3, -4, -5. Here we have 1, 2, 3, 4, and 5. So plot the point 2, 5. So we're going along our x = 2 and we're going up to 5. So here, and then -1, 1. So over here, -1 and 1 right here. Now we want to use our knowledge of Pythagoras' theorem to find the distance between the 2 points. Okay, so first I might just draw a straight line between them. So there we go. We've joined them together. So there we have it. And now we're going to construct a triangle because remember, Pythagoras' theorem is going to be talking about triangles. So let's draw the triangle. So that's one straight side there, and that's another straight side. We can make this a right angle. So you can see, well, it looks kind of like a triangle. We'll just leave it like that for now. So we need to figure out what both of the other sides are before we can find the hypotenuse, right? Because the hypotenuse is the distance we're trying to find. So I might just make the distance we're trying to red right here. So what is this distance here, this vertical distance? Well, you can see that in terms of the y coordinate, right? Because we're looking vertically. So we really look at the y coordinates when we look vertically. Well, we're starting from a coordinate of 1 and we're going to a coordinate of 5. So that means we have 4 squares here. So 4 units. And similarly, on this part here, we have horizontal. We can see we're starting from -1 and we're going to 2. So that's going to be 1, 2, 3 squares. Okay. Now, using Pythagoras' theorem, we know that this is going to be 5. You can also just use the Pythagorean triads. If you haven't seen that video already, please check it out. So we can say that the distance between the 2 points, the point 2, 5 and -1, 1, is going to be 5 units. So that's our answer there. And finally, question 3, find the midpoint between the 2 points. And finally, we have question 3, find the midpoint between the 2 points. So I've just erased everything. So we're going to do it again. So we have -1, 1, that's that point here. And we have 0.25 over here. So that's that point. Now to find the midpoint of something, right? What we generally do is we're going to average both the x and y coordinate. Okay, so what do we mean by that? Well, we have an x coordinate of 2 and an x coordinate of 1. So the average of 2 and 1, -1, sorry, is just going to be 2 plus -1, and we divide that by 2. That gives us half. So a half would be our averaged x coordinate, and our averaged y coordinate, well, that would just be 5 plus 1, divide that by 2. That's going to be equal to 3. So our midpoint would actually have a coordinate of a half, 3, which means we have a x coordinate of a half, which lies around here, and a y coordinate of 3, which lies around here. So this right here is going to be our midpoint. You can see it has a y coordinate of 3 and an x coordinate of a half. So hopefully that makes sense in terms of how to find the midpoint between 2 points. So now let's create a more generalized formula for the distance between 2 points. So let's consider 2 points, x1, y1, x2, y2. So what does that even mean, right? x1, y1 is just a random point. So I'm just going to make this point here x1, y1. So there we go. So that's a random point x1, y1. And let's say we have another point here. That's going to be x2, y2. So remember, what did we do last time? We used Pythagoras' theorem, right? So let's first try and construct a triangle. So you can see we have a triangle here between these. So what we first need to do is figure out what this distance is, so the vertical distance, and then figure out the horizontal distance, and then use Pythagoras' theorem to figure out the distance, which is d here. So the vertical distance, remember, vertical distance refers to y coordinates. So we want to look at the y coordinates. You can see that we're going from y1 to y2, right? Like y2 is here, y1 is here. So that means the distance between them would have to be the bigger number minus the smaller number. So y2 minus y1. Same thing here. We have x2 minus x1 because we're starting from x1 and we're going to x2. Now, you might be like, but how do we know if y2 is bigger than y1? It doesn't actually matter in this instance because when we use Pythagoras' theorem, we're going to be squaring them anyway. So even if one's bigger than the other, they're just going to be the negatives of each other. And when we square it, it doesn't matter. So let's actually write down what Pythagoras' theorem is now. So Pythagoras' theorem is our hypotenuse squared, so that's d squared, is equal to one side squared, so y2 minus y1 squared, plus other side squared. So x2 minus x1 in this case, all squared. So now to figure out d, which is what we want to square root both sides. So that's going to be y2 minus y1 all squared plus x2 minus x1 all squared. And this is the distance formula we use in coordinate geometry. So whenever we're given 2 points, we can find out the distance between them by subbing it into this formula. And we'll do more practice questions to sort of develop our skills in doing this. And like I mentioned before, midpoint formula is very similar to how we did it before. It's just averaging the x coordinates and averaging the y coordinates. So let me do a random point. Let's call this x1, y1. So that's a random point. And let's call this point here x2, y2. There we go. So the midpoint, I'm just going to join these together. You can see the midpoint is going to be roughly around here. But how do I know exactly what that point is? So remember, I need to average the x coordinates. So the first coordinate is the x, and that's going to be the average of my original x coordinates, which is x1 plus x2. I'm going to divide that by 2. And my averaged y coordinates, well, that would be y1 plus y2 over 2. And that is going to be our midpoint formula. So I've put a capital M here to describe how this is the midpoint formula. And we've simply just averaged the x's and averaged the y's, and that is our new coordinate. So let's have a go at this example. So please pause the video and then let's run through it. Okay, so hopefully you've had a go at the question. So now let's go through it together. So part A is, so we're considering the 2 points 2, 4, -4, -2. Find their midpoint. So for part A, remember, we just need to average the x's and average the y's. So the x coordinate, average these two. So it'll be 2 plus -4 over 2 and average the y's. So that's going to be 4 plus -2 over 2. And that is going to be 2 plus -4 is -2. Divide that by 2 is -1. And then 4 plus -2 is 2. Divide that by 2 is also 1. So part B, find the distance between the 2 points. So here we can plug it straight into the formula. So what we're going to do is we're going to say square root of x2 minus x1 all squared plus y2 minus y1 all squared. So let's just write down the formula again. So it's going to be this. Now, might be wondering, which one do we do as y2? Which one do we do as y1? It doesn't matter as long as the x2 and the y2s are together and the x1s and the y1s are together. So what I mean by that is if we let 2 equal to x1, then the 4 has to be y1. You can't have this being x1 and this being y2. It does not work like that. So let's just sub it into the formula. In this specific case, I'm going to say that 2 is my x2 and y2. So 4 is going to be my y2. So I'm going to say it's going to be 2 minus my x1. So that would have to be -4. So 2 minus -4 squared plus 4 minus -2 squared. So there we go. And that is going to be square root of 6 squared plus 6 squared, which equals square root of 72. And we can simplify that and say that's 6 root 2. And don't forget the units. That's very important. So 6 root 2 units is the distance between the 2 points. Let's move on to another example. The 2 of Sudat is mapped on a coordinate plane. Sudat High School is located at coordinate 2, 3. So let's plot that out. 2, 3. The 3 students, Or, Tony, and Z, are comparing their proximities to the school. They live at 4, 7. So 4, 7 would be off the map at this point, but we'll just say 1, 2, 3, 4, 5, 6, 7. 7 is about here. And then we have negative 1, 1. So that one's all right. Negative 1, 1 is here. And the origin respectively. So that's going to be this one here. So this is going to be Or, this is going to be Tony, and this is going to be Z. So who lives the closest? Well, it's pretty obvious that it's not going to be Or, but we can do the maths. So we can figure out the distance from each one to that point. So let's do Tony first. So distance of Tony, so I'm just going to do capital D with a mini Tony there. That's going to be the square root of, so Tony is coordinate negative 1, 1, right? So that's going to be negative 1 minus 2 all squared plus 1 minus 3 all squared. So I'm minusing it with this coordinate here. So that's equal to negative 1 minus 2 is negative 3. Square that is 9. 1 minus 3 is negative 2. Square that is 4. And that is equal to root 13. Then we have distance of Z. So remember, Z is at the origin, which is another way of saying he's at 0, 0. So we take the square root of 0 minus 2 all squared. So that's x2 minus x1 squared. And then 0 minus 3 all squared. And so that's going to be 4 plus 9 again, and that's going to be root 13. And then we can just do distance of Or for fun. So we have square root of 4 minus 2 all squared plus 7 minus 3 all squared. That turns out to be 4 plus 16, which is equal to root 20. So it turns out that Tony and Z are equally as close to the school. And part 4, a fourth student, Titus, lives exactly between Or and Z. How far does he live from the school? So keyword, exactly between. When someone is exactly between, it's basically the midpoint, right? So we need to first find the midpoint of Or and Z. So we'll go over here. The midpoint of Or and Z is equal to, we average them. So average the x values. So Or was 4, 7, and Z was was the origin, sorry, 0, 0. So that means we're going to say that it's 4 plus 0 over 2, comma, 7 plus 0 over 2. And so that means Titus lives at coordinate 2 and 3.5, or we'll just leave it at 7 over 2. And finally, we need to actually figure out how far he lives from the school. So once again, we just use our distance formula. So distance of Titus is equal to square root of 2 minus 2 all squared plus 7 over 2 minus 3 all squared, which is equal to 0 plus a quarter, because 3.5 minus 3 is a half, and that squared is just 1 on 4, and that's just equal to half units. So therefore, we can conclude that Titus actually lives the closest to the school, and he lives just half a unit away. Finally, we have another example. 3 points A, B, and C form a triangle. Show that this is a right-angled triangle. So how do we show that something's a right-angled triangle? Well, we need to show the Pythagorean property holds. So really, we need to figure out every single side and then show that the two shorter sides, when squared and added together, is equal to the third side squared. So how do we do that? Well, first, it might be a good idea to draw up a Cartesian plane, just to give us an idea of what we're looking at. So this is my x coordinate, this is my y coordinate. Here I have the origin. Now A is negative 2, 1. So negative 2, let's say, is here, and that's 1. So we'll call that point A. Then point B is 2, 3. So it's about 2 and further up. So about here, let's say that's about 3. So that's going to be point B. And then point C is 3, 1. So that's going to be 3-ish and 1. So there we are, point C. So we need to draw the triangle now. So let's draw it here. And already you can see it kind of does look like a right angle triangle, probably here, but we can't be certain. So first, let's figure out all of our distances. So let's start with distance AB. So we use our square root distance formula. So we're going to be using this coordinate and this coordinate. I'm going to be doing A minus B. So that means -2 minus 2 all squared plus 1 minus 3 all squared, which is equal to 4 squared. So that is going to be 16 plus 4, which is root 20. And then we have distance of BC. So the distance of BC is going to be square root of 2 minus 3 all squared plus 3 minus 1 all squared. You can see I've done 2 minus 3 and 3 minus 1. That's equal to 1 plus 4, which is root 5. And finally, we have the distance of AC, which is equal to square root of -2 minus 3 all squared plus 1 minus 1 all squared, which is equal to square root of 25 plus 0, which is just 5. So now you can see that the two short sides, AB and BC, if they're squared together, root 20 all squared plus root 5 all squared, that leads to 25, right? Because root 20 all squared is just 20 plus root 5 all squared is 5. So 20 plus 5 is 25. And that is the same as 5 squared. So we've shown that the two shorter sides, when squared together and added together, is equal to the square of the third side. And therefore, we've proven Pythagoras's theorem holds in this triangle, which means angle ABC is equal to 90 degrees. So hopefully that makes sense. And finally, the last example of this video, suppose X represents the number of hours in individual studies and Y represents the mark this paper gets in the exam. In a class of 8 students, the teacher has lost 1 student's paper. The 7 other students are expressed by the following points. 2, 20, so that means they have an X coordinate of 2 and a Y coordinate of 20. So they've studied for 2 hours and got a mark of 20. Next person has studied for 3 hours and got a mark of 32. And so we've got all this. So part A, plot the points on the graph. So you can see it's kind of difficult to do so on this graph, but you can see we've got points for, in terms of our X values, they range from 2 all the way till about 8. So let's say intervals of 2. So 0, 2, 4, 6, 8. There's no negative hours, so we can actually ignore the entire left side of the graph. And you can see the marks they got range from 20 all the way till, oh no, it starts from 15. So 15 all the way till 73. So we can use, let's use intervals of 20. So we're going to get 20, 40, 60, and 80. Now we can plot all the points. So let's start doing that. So 220. So 220 is this point here. Then 332. So 3 would be between there. 32 would be about there. 547. So 5's halfway between them. And then 47 would be slightly here around there. And then we've got 5.5, 62. So 5.5 would be about here. 62 would be just above there. Then we've got 115. So 1 and 15 about here, I would say. Then we've got 873. So 873 would be about there. And then 3.5 and 40. So 3.5 just about here. And at 40, so just there. So you can see we've got our collection of points that have been plotted. Now, part B, explain what each point means. So I've already said that. Each point represents how many number of hours each individual studied and the mark they got. So for example, this point here, this individual studied for 5.5 hours and got 62%. I don't know if that's a good trade-off or not. I guess if you study more, you might get higher marks, but it really does depend. And part C, the teacher knows the last student studied 9 hours. How could you predict their mark? So you can see here that these dots sort of make up a line. So I can, using computer software or even just looking at it, can see there's a little bit of a correlation per se. So maybe like a dotted line like that. So if they study for 9 hours, they would be having an x coordinate of here. And if you look at that all the way on our line, well, we can expect that person to probably get a mark above 80. So that's how we use predictions and statistics to sort of explain or predict what a student's mark might have been. So that's just one example. So hopefully in this video, you've got a good idea of what the coordinate plane looks like now, the Cartesian plane, the x coordinates, the y coordinates, the origin, and you should have learned how to find the midpoint and the distance between 2 points. So hopefully that'll make sense. In our next video, we'll be talking about the slope/gradient of a line. So hope to catch you in that one.